Well, this paper is really interesting for me because I'm really interested in structured prediction, which is a kind of generalization of supervised learning. And it is very important for machine learning. If you do structured prediction, you can do it for computer vision, NLP, speech recognition, better speech recognition, state-of-the-art algorithm for many tasks. So structured prediction is very important, and we have seen it on dependency parsing or other application. But here, instead of relations between words, higher order relations that we use for dependency parsing, in argument mining we are working on relations between sentences, and we want to know what is if they support each other or attack each other, and also we want to know the structure of the graph that is produced. So I want to explain this article. So Vlad is an expert in structured prediction, and he has written many great articles in Amsterdam University. Oh, this is written at Cornell University. So these are amazing approaches to deal with machine learning problems if we implement it as why do we need structured prediction? Because if you just use a naive deep learning approach, you are just taking the first order relations. You are not capturing the high order relations, which have very much informative. And so let me tell you an example. For example, want to note the relation between these arguments. This is a fact, this is a policy, and if you just work on simple deep learning, you just get the first order relations. But for example, you cannot capture co-parenting or siblings or other higher order relations that we've done in dependency parsing. So here we have some sentences. We want to know the relations between them, and so the higher order relations are very important. The proposition types that they use are now a little bit different in this dataset. For example, they use policy, value, testimony, fact, and reference. So policy and value contain subjective judgments, interpretations, where only the former specifies a specific course of action to be taken. On the other hand, testimony and fact do not contain subjective expressions, the former being about personal experience. Finally, reference covers URLs and citations which are used to point to objective evidence in an online setting. So they use two datasets. Firstly, the corner rulemaking corpus, and the other one is this UKP by Professor Gurvich. So the idea is to model the correlation between proposition and link prediction, and we use factor graph. It's very important in graphical models, and we can capture many high order relations in different tasks such as dependency parsing, argument mining, and many applications in computer vision. So this is a factor graph. For example, the unary potentials say that, for example, what is the probability that what is the score that this is, for example, is policy or value? What is the probability that this is, for example, testimony? And once it is value and testimony, what is the relation? What is the probability that it goes from testimony to policy or any other combination? Because some of them we want to encourage them, some of them we want to discourage them. So some of them are positive samples, some of them are negative samples. And you see that we can capture several types of higher order relations, such as siblings, co-parenting, grandchildren, and so on. But let's stick to just three of them. For example, co-parenting, sibling, and grandchildren, because these are very important higher order relations. Just like dependency parsing, here in argument mining, we want to capture the maximum score that you obtain. And this score is the summation of the constituents. And so for example, when we say there is a relation between A and B, it's either on or off, so each one is a different proposition, because each one could be either policy, value, fact, testimony, or reference. But in other datasets, they just use premise and major claim and claim. So in the UKB datasets, the links are within each paragraph. But in the CTCP dataset, the links are all possible. And the link structure for that could be like this. But for UKB dataset, the 3-factor over each paragraph or 0 potential root. So I said about unary potential, you just say what is the score that it is, for example, testimony. And the compatibility factors make sure that we encourage something that is more seen in the dataset, or discourage something that is never or rarely seen in the dataset. And you see these are second order factors. For example, it can go from, so this is a kind of let's say siblings, brother or sister, and then co-parenting is like this, D and E, co-parenting, because one child can have 2 parents. And grandchildren, for example, A goes to B, B goes to C. So this is the children, this is the grandparents. And the valid link structure, this is something that is not natural, but this is an idea that is used in this article. And finally, the inference. For inference, as you have seen my playlist for dual decomposition, you can use all the techniques of Professor Martin that I've explained. He uses a very nice algorithm for dual decomposition. For learning, you can use this hinge loss. So rho is your misclassification cost, usually constant, but here you can use for precision, we can make it like this, but your margin could be either constant or dynamic. So the argument structure support vector machine, they use this for argument structure. They use argument structure recurrent neural networks so they model the link production like a bilinear transformation. For example, what is the score that go from testimony to policy? Because you have encoded these A and B, these arguments A and B, we can use just a bilinear combination of them, and then we can measure this score of this relation in your graph. Or of course you can use a second order model as well. And finally, these are the results. So this is policy, value, fact, testimony, and reference. And this is the confusion matrix that they've reported. And they are grateful to Andrew Martins because he has done a great job on dual decomposition. And so let's review what is this corpus of rule making. So this testimony is an evidence for this fact. This fact is a reason for this value. So we have a different set of labels and arguments. So this is an example of evidence that 1C is an evidence for 1b. So 1c is here, this is 1c, this is an evidence for the fact b. B is here, so this is a fact that $400 is enough compensation, and we can obtain these relations. So these are elementary units that we should be familiar in law. That fact is a proposition of non-experiential fact, and proposition of experiential fact is the testimony. For example, informing them if we wanted all debt collection to be written was also ignored. A neighbor who has since moved away has had their debts turned over to collection agencies. And we have also value and policy that you can read and understand what are these means in law. And also we have reference. This refers to the reference to a source of objective evidence. And we support the relations that we have are either reason or evidence. For example, an elementary unit is a reason for proposition y if x provides rationale for y, or evidence. And the elementary unit x is an evidence for proposition y, which is, for example, this is of type policy, or value, or fact, or testimony, if it proves whether proposition y is true or not.